Hello guys, welcome back. Let's see a classical DP problem, edit distance. So the problem is in minimum number of operations we have to convert SUNDAY to SATURDY. So in minimum number of operations we have to convert Sunday to Saturday. So in the previous video I explained about the cheat sheet. So you are a creator, you should evaluate the choices and write down the recursive function. Let's do these three things and get back to the rest of the steps. Okay, so here when you have the two letters are same, okay, you need not convert anything. As the both are same, you need not convert. So we can ignore these two letters and try to find out minimum number of operations required to convert this string to this string. Now again, if you see A and A both are same, we can ignore and we have to find out minimum number of operations required to convert this string to this string. Again, if we ignore A, we will end up like this, SUND and SATURD. But again these two letters are equal, so we just ignore these two letters and we have to find minimum number of operations required to convert SUN to SATUR. Okay, now in this case these two letters are not equal. So what are the choices we are left with? We are left with three choices, just as the two robots problem. We are left with insert, delete or replace the characters. So replace the characters or delete the existing character or insert a new character. Here we are trying to convert SUN to SATUR. Okay, so the operations looks like this. We replace a character, so we have replaced N with R. We are trying to convert this string to this string, so we have to replace the strings with, we have to replace the characters with Saturday's string characters. So here I am trying to replace N with R. So as these two strings are equal, now we have to find minimum number of operations required to convert SU to SATUR. This is one option. Okay, if we replace the string. Next, if we delete a string, yes, if we delete the N, okay, then we are left with this. So we have to find number of operations required to convert SU to SATUR. Right, when we delete N, we are left with this substring. Okay, let's assume we insert a new string, insert a new character. So we have inserted R over here. Okay, now R and R, these two strings, these two characters match, so we have to find minimum number of operations required to convert SUN to SATU. Right, I hope you are understanding. Okay, let me rewind again. So while replacing, we have replaced N with R. As these two characters are equal, we have to find minimum number of operations required to convert SU to SATUR. Now I delete N, so I am left with this substring. So I have to find minimum number of operations required to convert SU to SATUR. Now deleting, inserting, sorry. So I am inserting R beside SUN. So these two letters are equal, so I ignore them and I try to find minimum number of operations required to convert SUN to SATU. So these are the three operations that I am left out with. Okay, so let's write a recursive function with base cases, and also these are the things that you have to keep in mind while writing a recursive function. So while writing a recursive function, you should always think of first level depth. Okay, so don't try to think about the 11th or 12th depth level and screw up your recursive function. Recursion is a magic function which does a magic and returns you the correct answer if you ensure that first level depth works perfectly for all the cases. Okay, so this is a warning, don't go beyond the first level depth. So if you think of recursion tree for edit distance, it will be more or less like this. So you have to find minimum number of operations required to convert one string to another. So you may apply insert for the two strings, and you may apply replace or you may apply delete, and internally again in the insert, after entering the insert state, it will again try to apply insert or replace or delete for the existing strings. Okay, or if you replace string and if you try to enter the edit state program again, it will either insert or replace or delete. So this more or less the tree will be like this. Okay, don't get confused with this. So for any state that you enter, it will try to apply the insert, replace or delete. So just remember that one. So here initial state, it will apply insert, replace, delete. Again for insert, it will apply insert, replace, delete. Okay, this keeps on going, this entire tree will keep on going. So in the next video, let's write a program for edit distance, recursive program for edit distance, and after that you can get a better clarity over that. Okay, see you, have a nice day.